Before my battery runs out. Back in SoCal. I'm over here at this place called Sunset Beach, which I guess is a part of Huntington Beach, which I guess currently flies under the Trump flag still. Anyway, we got our classic Instagram people over there, you know, casual beach goers. And I'm over here trying to pull some Actinopterygians out of the water in front of everybody. Conditions look pretty good. All right, if anybody watching my video is a fisherman, wants to know what I'm using something called a Carolina rig. It's where you have this little egg-shaped sinker right here. I'm not gonna explain how to make this rig. I'm just telling you what it's called. It's a Carolina rig, that's what they call it. And the idea is the weight sits at the bottom of the sand, and this hook is free motion to swing back and forth with the waves. Kind of like feeling out, presenting the bait to whatever fish might be out there. All right, for bait, I'm using this organism called Arenicola melina, otherwise known as the lugworm. Right there, it's a type of polychaete, which is an annelid. It's in the phylum Annelida, which are segmented worms in the class Polychaeta, which mean worms that have these little bristles kind of on the sides of their bodies. Each segment has like a set of bristles. Apparently these are very good bait. They can kind of bite you too. They inside their mouth, they can kind of like reverse their throat, and in that throat they have like little spikes and teeth almost. So these are little predators that would naturally burrow in the sand and eat any organisms living within the matrix of the sand. Anyway, I'm about to chop one up and put it on the hook. I guess this feels like a good time to share some thoughts. I'm here in Southern California at this place called Sunset Beach, which is in Orange County, you know, the area of the United States full of, I don't know, probably the highest density of closet racists in the whole country. But, I mean, like, it's got some nice beaches. I mean, I guess we're more closer to LA County, which I know it's probably like Orange County rejects. I know there's some term called the Orange Curtain. I don't think we're a part of it. Anyway, I'm rambling. But like, I don't know, you can see way out there, you got all these ships and stuff because the port of Los Angeles is right there. Probably the goods that you're used to buying, you know, your PlayStation, Fitbits, pieces for your iPhone and all that stuff. Like, they probably all come through here. Yeah, so this is a pretty locally famous beach. A lot of surfers come here, a lot of just standard beach goers, and like myself, fishermen come here too. You see all these houses right here, and like all this sand has to get like trucked in. The natural current systems of Southern California tends to pick up all this sand and deposit it other places, so they actually got to kind of dredge it back up in the ocean and redeposit it here so they can maintain the area of the real estate. But with that being said, I mean, they're bringing in soil essentially. I mean, even though this is all sand, it still counts as a soil. You know, there's still ecological function going on in this soil medium. But I wonder who knows the specifics. I really don't know the specifics. I can only make inferences based on what I'm seeing out here in the field. You know, sort of these in situ pieces of evidence. And that's kind of give me ideas of what might be going on around here. Case in point, I just you know, pulled up one of the very common pieces of, we call it litter. Just call it litter. One of the common pieces of litter. This is a Cheetos bag, or what's left of a Cheetos bag. I think you get the idea of where I'm going here. Yeah, so first off, I mean, I'm thinking about where we're at. The port of Los Angeles is just like right over, I don't know, maybe about 10 miles that way. So you can tell this is a busy part of the ocean here in Southern California. And not just busy because of ships, it's also busy because of recreation and everything else pretty much. So other than all that's going on out there, I'm noticing everything as I'm walking along the beach. And normally you would see natural things like these seashells from these mollusks. You would see a lot of this Macrocystis pyrifera, which is the dominant kelp species here along the Southern California coastline. You can see right here, there's like some feathers and stuff from seabirds that have fallen off of them while they're flying in the ocean. Just a bunch of organic material. California mussels right there, my love. Featherboa kelp right there. And then as you can see, as this kelp floats up on the beach during high tide regimes and gets left up here, it becomes a resource for other animals. Right here we have these flies, which are likely in the family Anthomyidae, and they're feeding on the kelp right now. They're probably like just using those mouth parts with those digestive fluids that they can secrete from their mouth to digest the kelp. And you know, in the process of doing that, they're pooping and adding nitrogens and other nutrients to this sandy environment right here. And consequently, because you have organisms like these flies, and it won't just be these flies too, you'll have these crustaceans, amphipods, and isopods that don't fly around. They live in this stuff right here. They come in with the ocean currents, and they'll also break this stuff down too. So once they break it down into little pieces and into a smaller chemical constituents, you know, that can get mixed in with the water, and then in turn provides nutrients for plankton out there for them to take advantage of, grow bigger, and then they get eaten by larger planktonic organisms, zooplankton, animal plankton, and those get eaten by smaller fish, then by bigger fish, and so on, until it gets eaten by the tuna that you get in your poke salad sometimes. I don't know. So yeah, I can see that there's a great deal of nutrient cycling that occurs in this particular ecosystem, where you got this idea of ecotone, meaning you have this boundary right here that separates terrestrial from marine ecosystems, and a whole lot of interactions going in between with the organisms, and death and decay and all that stuff, even reproduction going on in this little sliver, this little divide between the ocean and land. So the thing that kind of bugs me, that kind of grinds my gears, is like, as I'm walking here, you know, not just all this organic material, you're seeing shit like that. You know, you get even closer and you can see that there's even smaller pieces of that. And you know what I'm talking about? I'm talking about plastic. So just like this organic matter, this plastic can also get broken down by who knows what, whether it's wave pressure getting knocked around against things, or maybe even smaller animals. God damn, look how much. Jesus. Bigger pieces, smaller pieces, massive pieces. It's just all up in here. You can see it all right here. I mean, this is why it pays to look closer, so you can see what's really going on if you like the beach, you know. We have, I don't know how many people know this, but plastic is it's made from oil, you know, so it's made from hydrocarbons and everything. But those hydrocarbons, the way that they're formed, you don't really see a lot of that naturally. So it can influence certain chemical reactions in whatever ecosystem that the plastic might be in. And when I see it here, I kind of question what's exactly going on. You know, how much of this plastic is influencing the soil system, or the sandy ecotone system here on this beach. And I also wonder how the organisms that are alive today, if and how they are adapting to this new ecology that is going to be present probably for millennia. I'm not saying life is all going to die, but I wonder how it's going to evolve with this literal new resource that Homo sapiens have been adding to ecosystems everywhere around the world. I mean, that's just the truth. So yeah, this pretty much looks like the future of the California coastline. And honestly, every coastline that has sandy beaches all along the world. I mean, even in those nice spots that you see in all those vacation brochures and all that stuff, I'm pretty sure there's microplastics like this landing on those shores, and also influencing the chemistry of the sandy soil communities on those beaches. right here. Yeah, so you got this dead bird. I think it's a dead pigeon, Columbia livia. I don't know, I'm not gonna touch it. So you got nitrogen from animal corpses too, also influencing the soil chemistry of this place. Oh, look, there's evidence of dogs here. Dogs poop on the beach. More nutrients added to this system. And again, look at those anthomyids just going to town. You know, the flies, they eat dead things. Yeah, I'm thinking this pigeon probably got taken out by a peregrine falcon. And this is just what it left when it got full. But yeah, so as you can see, like even this dead corpses here on the beach are adding nutrients, like essential nitrogen, to the soil, which then in turn make it out into the ocean. I don't know, maybe this is just my way of trying to maintain positivity. I just want to see how it changes stuff, you know, because shit's gonna change. And probably, I mean, it is changing already. So I want to see how it changes, because there will be organisms adapting to this type of change. There will also be organisms that can't. And I guess the main concern for Homo sapiens here on planet Earth is whether they can cope with the changes and also fall into the category of organisms that will end up evolving. But I don't know. Anyway, that's it. Bye from sunny Southern California.